Calculus in Motion, a series which can help you ace your exam like a pro. Reason is simple. We discuss with you real problems from past test papers. They really make a difference. So now we are discussing Unit 3, Higher Order Derivatives. One by one, there will be questions shared with you. And for each problem, step by step solution will be provided by me. That should help you to max your papers. I'm Anil Kumar. Welcome to my YouTube channel, a learning platform absolutely free for the last 15 years. In this video, we have taken up another beautiful question based on higher order derivatives. This time, the equation for us is a polynomial equation. The question here is: position of a car at t seconds moving along a straight line is given by s of t equals to 1/3 of t cube minus 2t square plus 3t, where s is measured in meters and t is greater than equal to 0, which is measured in seconds. What are we going to learn here? Well, learn when does the car return to the initial position, when is the car at rest, determine the duration when the car is returning, explain if car is changing the direction or not, when is the car slowing down or speeding up also, right? So with that, let's begin our solution. Now before that, let's take what basically you need to understand before getting into the solution of these questions. First key takeaway is that velocity, as you know, is the first derivative of position. What we are given here really is position of a particle, in this case, a car. So velocity is the first derivative of position, acceleration is second derivative of position. You can say acceleration is rate of change of velocity, right? So now that is what we mean by saying higher order derivatives. Rate of change of position is velocity and rate of change of velocity is acceleration. So that is a higher order derivative. Now, after finding the derivatives, we'll look for different conditions, which will tell us when an object is at rest. It is at rest when velocity is zero. An object returning means displacement and velocity product is negative, right? So, this is kind of very critical to understand, which is the main question here. An object speeding up. Object is speeding up when the product of velocity and acceleration is positive. And when is it slowing down? It slows down when their product is negative. Makes sense, right? And now, with the help of a graph, I'll show you how do we understand these solutions. Many times the question could be based on the graph itself. So that also you can answer once you understand all these strategies. So now let's begin by answering them one by one. So the very first one here is we are given the displacement equation, which is s of t equals to 1/3 of t cube minus 2t square plus 3t. Step 1, we are trying to finding when the car returns to initial position. Now, what is initial position? Initial position means if t is 0, then what is the position, right? So let's write down t is 0, right? So t is 0 means 1 by 3 of 0, right? Minus 2 times 0 plus 3 times 0, so that is 0. So initial position is at the origin itself. You get the whole idea, right? Okay, so the question now is when the car returns to the initial position. So this is okay, t equals to 0, it is at 0. But when else, right? So basically, we'll now try to solve the equation that this displacement is 0, means after what time? This is what we have to figure out. So let's plug it in and try to figure out what is the time when it could be 0, right? So take t common. You can also take 1/3 of t, right? So we get t squared minus 60 square, 60. And this will be 3 times 3, 9, right? We have taken t common, so one third of t is a common factor. And clearly, for this equation to be 0, using 0 principle of multiplication is 1. When t is 0, the other one, when this factor is 0. Now, this factor is a perfect square, you can see, right? 3 square is 9, and 3 times 2 is 6. So I could factor and rewrite this as one third of t times t minus 3 whole square. So from here, we know that at t equals to 0, s equals to 0, and at t equals to 3, also s equals to 0. You see that? So when is the car returning to initial position? Car returns to initial position at t equals to 3, right? So we can write down car returns to initial position at t equals to 3 seconds. Is that clear to you? So that is the way we are going to answer the first part of this question. Now, second question was, when is the car at rest? Now, for car to be at rest, velocity should be 0. So we'll now find the derivative of the function, which is displacement function s of t equals to one third of t cubed minus 2t squared plus 3t. So velocity, which is the derivative of displacement, will be one third times 3t squared minus 2 times 2t plus 3, right? Which is t squared minus 4t plus 3. Now we can factor this, right? So velocity can now be written as 3 times 1 is 3, and both minus will give us minus 4. So t minus 1 times t minus 3. Now, for velocity to be 0, t is equal to 1 or t equals to 3. You get the whole idea. So, these are the two times when the car is at rest. Right? So, we can now write down our answer. Car is at rest. Or you can say at t or after. So, at t equals to 1 second and t equals to 3 seconds. Makes sense, right? So, basically, what has happened here is that the car moves along a straight line. So, let me just show you here. Right? So let's say this is the starting point, t equals to 0, right? So it moves for 1 second, it goes right. And then it returns. You get the whole idea. That is what it means. Correct? And we earlier saw that after 3 seconds, it is back to the initial position. So it returns to the initial position and then will go back. Does make sense, right? So this is t equals to 1, and then this is t equals to also 3. So that is how you can visualize the displacement of the car along a straight line. Makes sense, right? Let's move forward. So we got the expression for velocity in the factored form as t minus 1 times t minus 3. Now it says, determine the duration when car is returning, right? So car is returning means, let me sketch that graph once again along a straight line. So we say at t equals to 0 and at t equals to 3, the car is right there, right? So initially, the car moves straight and then it returns and then it again goes. That is how the cubic function displacement will be depicted along a straight line. Now, this happens at t equals to 1, and this happens at t equals to 0 and 3. Right? 0 is the starting point, right? So that is where it starts really. So now the question is, determine the duration when car is returning, right? So the car is returning when? when t is between 1 and 3, right? So that is the returning period. You see that point. So that is how you're going to write the interval during which the car is returning. There are only two turning points which we have found, right? At the turning point, velocity is going to be zero, right? So note, let me write TP as turning point, velocity will be equal to zero, correct? And there are only two. One is at t equals to 1, the other one t equals to 3 seconds. Makes sense, right? Let's move forward. Now, here we have, does the car change direction? It does change direction. And as we have seen, it does it twice, right? So, once again, this picture really helps, right? So, it changes direction twice. It starts like this, comes back, and moves, right? So, twice. Now, these are communication questions, right? So, many times these are important and they have to be explained. And the diagram, which we are trying to show you, helps. So, it changes direction. So, at t equals to 1 and at t equals to 3. So, these are the two times when it changes direction. This is when t equals to 1 and this is when t equals to 3. Perfect. So now let's look into the condition. When is the car slowing down? Now, for slowing down, let's understand what should be true. So, for slowing down, the velocity and acceleration product should be less than zero. That is where it slows down. So, that means we have to find both the functions, right? And the interval where both are negative, right? So let's find the velocity. Well, velocity we did find earlier. So when you do the derivative, you get t squared minus 4t plus 3, which can be written as t minus 1 times t minus 3. Now let's find acceleration, which is derivative of velocity. So we get 2t minus 4. Correct? So that is the acceleration. Now to analyze this, what we can do is, let's sketch the graph. We can make an interval table also, right? So we know it's a parabola of a velocity. So the velocity basically is being depicted like this. So that is the velocity graph, right? So it was positive, and at this point, it is returning, correct? This is when t equals to 1, this is time t, right? This is at 3. Now, as far as the acceleration goes, let me use a different ink for acceleration. So we could rewrite this as 2 common, t minus 2. So if t is less than 2, it is negative, right? So at 2, it is positive. So it is kind of like this. So this is the graph for acceleration. And the point here is at 2. Now from the graph, it is very clear that, let me also sketch this part here, which is t equals to 0. Now it is very clear that the interval during which they have opposite signs is from here to here, correct? And from 2 to 3. So you can see acceleration and velocity have opposite sign when t is from 0 to 1 and when it is from 2 to 3. Make sense? So from the graph, it is absolutely clear. We can do it with the graph, or you can make an interval table to do it. But I prefer, while working with quadratic and linear equations, graph is better. Perfect. So that is the duration when the car is slowing down. Makes sense? So that is how we are going to answer this particular question. That's a good idea to actually see it on the actual curve, which I've used a graphing calculator to sketch. Now, here we have seen the velocity graph. That is the axis, which these 2 points are at 3, and that is the starting point, and this is the velocity graph. And on this, we kind of made a displacement graph also, acceleration graph also. The acceleration graph was kind of like this. And the slowing down is when they have the opposite signs, so positive and negative. You get the whole idea up to this point. And then from 2 to 3, you see they have opposite signs. So it makes sense, right? So that is how we are going to answer this particular question. So I hope with this you have understood how to work with higher order derivatives relating displacement, velocity, and acceleration. We have understood the key concepts for when does a particle return to the initial position, when is it rest, when is it slowing down. The other intervals are when it is speeding up, right? So all these questions I hope are absolutely clear. Feel free to write your comment, share your views. If you like or subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.